Here's the paper that you did recently. We're going to look at question 3, and it starts with a sketch of a curve. So to remind ourselves of what a reciprocal graph looks like, we get the old calculator out. I'm in graph mode, and I've typed in the equation y is -1/x². So we'll sketch that. Okay, we may need to adjust the view window, so I'm going to use the initial version. It's a little bit easier to see. We can see that it's a curve that approaches the x-axis and the y-axis but never crosses them. So the x and y-axes are asymptotes. So I'm going to try and sketch that. Wish me luck. Okay, we have to be a little bit careful when we're doing one of these ones. We have to show that we are approaching the axes, but we're not touching them. We have to be careful that we don't curl the graph downwards. We don't make it ever completely flat. We don't let it touch the axis at all. Okay, so it is quite tricky. So I'll put that on there. There we go. So that's part A. Now then, for part B, okay, it says that this curve is translated by 2 units in the positive x direction, and we have to state the equation of the curve after the translation. Okay, so it's been translated to 0 in the x direction. So if you start with a function y is f of x, then when you're performing something in the x direction, you replace the x with something. If it's a translation, it's an add or subtract. So it's x, and because it's the x direction, we always do opposite to what we think. This says +2, so we put -2 there. So let's just think about what that means for our function. So our function y is -1/x². So all I'm going to do is I'm going to write the same equation, but wherever I see an x, I'm going to replace it with x -2 squared. And if I want to check I've got it right, just go on my calculator, and I'm going to type in -1 over, and then brackets x -2 squared. Okay, and when we draw them, there's the first one. Yeah, the second one looks like it's been translated across. Super. So, the last part of the question, part C. So the original curve is now stretched parallel to the y-axis with scale factor 1/2. And as a result, the point 1/2, -4 on the curve is transformed to the point P. We just need to state the coordinates of P. Okay, so for this part, we are stretching in the y direction a scale factor 1/2. So if we think about what that would look like on the graph, we're kind of just squashing it towards the x-axis. Okay, all the points are getting squashed in towards the x-axis. And then if we think about our point, so 1/2 -4, if we're doing a transformation in the y direction, we're only going to transform the y coordinate. So this point will get squashed towards the x axis, okay, and we'll be multiplying the y coordinate by 1/2. So that means we should keep the x coordinate the same, halve the y coordinate. We can check it on the calculator, so I'm going to just write in my function, so negative, and it will be 1/2, okay, multiplied by my function, so 1/x². Okay, so if I now draw that, my second one is a little bit squashed up there. I'm going to use trace, and I'm going to type in the x coordinate is 0.5. So I'm on my first original graph at the moment. If I want to follow along my graph, then I can do moving to the left and right. Okay, but if I want to switch to my new transformed graph, the stretched one, I move the up and down arrows. So if I move up, I'll go to the other one. There we go, and we can see the coordinate, the x-coordinate stayed the same, but the y-coordinate has gone to -2.